Reliability improvement of cooling water pump, guided by P. Yogesh, and project members are R. Karthik, N.S. Vamsi. Abstract. The project presentation an idea of analyzing the stress concentration occurring on the shaft. In centrifugal pump, there are frequent failures of the shaft during operation, due to which it leads to breakdown or stop of pump working and regular maintenance is conceived. In this project, to recognize the shaft failure, we have calculated the load acting on the shaft and forces exerted by the impeller. The stress analysis of shaft is done by ANSYS software and finally gives suggestion to improve the life of the shaft. Introduction. Centrifugal pump. A centrifugal pump is one of the simplest pieces of equipment in any process plant. Centrifugal pumps are used to transport fluids by the conversion of rotational kinetic energy to the hydrokinetic energy of the fluid flow. Its purpose is to convert the energy of a prime mover first into velocity or kinetic into the pump. The energy changes occur by virtue of two main parts of the pump, the impeller and violet or diffuser. The violet or diffuser is the stationary part that converts the kinetic energy into pressure energy. Common uses include water, sewage, petroleum and petrochemical pumping. Main parts of a centrifugal pump. The following are the main parts of a centrifugal: impeller, casing, suction pipe with a foot valve and strainer, delivery pipe. This is centrifugal pump. Visual inspection observation. Failure occurred at the end of lock nut towards non-driven end. The failure appeared is fatigue fracture. Factors contributing to pump failure: insufficient NFSH, pump speed above rated, misalignment of mountings on the shaft, overload failures, fatigue failures. Misalignment of mounting of shaft. The misalignment of mounting on the driven end has imposed more stress at the non-driven end. In the driven end, we have a lot of protection in comparison to the non-driven end. As the lock nut towards the non-driven end is positioned where more stress concentration factors has been taken place. Overload failures. The overload failures are caused by the forces that exceed the yield strength or tensile strength of a material. The appearance of an overload failure depends on whether the shaft is brittleness. Fatigue failures. Fatigue is caused by cyclical stresses and the forces that cause fatigue failures are substantially less than those that would cause plastic deformation. Confusing the situation even further is the fact that corrosion will reduce the fatigue strength of a material. Once they are visible to the neck, the cracks always go perpendicular to the plane of maximum stress. Type of shaft breakage in this case. Life of shaft. The pump shaft fails after 3000 hours of operation approximately. Expected life of shaft is 10 years. This is shaft diagram. Shaft drawn in CATIA. This is model of CATIA. This is tabulation about the NPSH minimum height of the submergence. It's, it's shown in tabulation. Pump details. Weight of the shaft is equal to 147 kg. Weight of the impeller is equal to 256 kg. Width of impeller is equal to 105 millimeter. Inner diameter of impeller 530 mm. Outer diameter of impeller 640 mm. Weight of impeller 256 kg. Material of shaft EN8. Material of key mild steel. Calculation. Tangential velocity at inlet U1 is equal to 27.73 meter per second. Tangential velocity outlet 33.17 meter per second. Discharge of water Q is equal to area of inlet into velocity of flow. Therefore, VF1 is equal to 3.4 W8 by S. Discharge area of outlet into velocity. Therefore, VF2 is equal to 6.7. Tan theta is equal to V1 by U1. This calculation are taken from the thermal. Is efficiency of the shaft. Calculation of work done by the impeller per second is equal to centrifugal force produced by the impeller. Manual shear force and bending moment calculation. The shaft is considered as a simply supported beam with bearings as the support. Load acting on shaft is equal to 8007 to 1.0. Load of length of shaft is equal to 1637.5. This is bending moment calculation of shaft. The maximum bending moment at the center RA is equal to 818.75 is equal to 33097 Newton millimeter. This is shaft analysis using the ANSYS software. It's shown in figure. This is shear force diagram by using the ANSYS software. This is bending moment diagram by using the ANSYS software. Is bending of the shaft. Conclusion. As a centrifugal pump is used in very wide variety of applications, so it is quite necessary to measure the various pump performance parameters for the efficient operation of centrifugal pump. But experimental studies to determine different performance parameters in different type of pumps are complex, time consuming and costly. The combined action of environment, geometry and fatigue stresses might be causes for the crack initiation. The final stage of shaft failure is resulted by the mechanical stresses. Recommendations. Care to be taken to check the misalignment of mounting the shaft. Preferred corrosion coating materials should be used for protecting of the shaft from the atmospheric environmental condition. Possibilities of other stress reduction method are to be explored in future. Changes are to be made in the shaft key. Thank you.